Thank you so much for joining me today. I want to welcome you to Making Memories with Semgrep Assistant. Today, I'm going to talk about making the most of Semgrep's AI solution by creating memories, which is our way of allowing Assistant to learn and grow with you and your application security program. We've got some people still joining here, but I'm going to go ahead and get started. Um, and for those of you who may need to drop off halfway through, we're of course recording. We'll be able to share with you once this workshop has concluded. So who am I? I'm Jason Kinsfather. I'm a former developer turned to the application security side of the house. I work primarily with mid-sized companies, helping them scale their application security scanning programs with Semgrep. I'm a bit of an AI skeptic, but I've come to kind of appreciate the power of AI as I've seen it in the hands of my customers, and that's kind of helped me change my tune. Now, if you aren't familiar with us, Semgrep is an application security scanning platform, and we have an audacious mission of profoundly improving software security and reliability. Now, it's pretty generic. So the question is, how are we going to do that? Well, we want to provide fast, flexible, and easy to customize static analysis, component analysis, and secret scanning that really helps integrate into developer workflow and deliver on the promises of shift left. Now, every single one of you that's on this call has heard of shift left. You know what that means, and we know what the promises are and the benefits of it, allowing developers to move faster, fixing issues earlier. But a lot of the time, what people call shift left and what it ends up being is actually just a fire hose of issues that we turn on and we hit the developers with. These issues are typically unvetted and they can be hard to triage, kind of noisy, and that wastes developer time and their confidence in the security team. So here at Semgrep, we really try to deliver on shifting left, but in a way where we can promise our developers, first of all, we're only going to raise issues to you that we think are true positives. And two, if we do raise something to your attention in your workflow, we want to provide you with easy guidance for triage and for remediation. And that way, your time is respected and you can easily work with the findings that we have to offer. Now, traditionally, Semgrep has given multiple knobs and levers to help you control what is surfaced to the developers versus what is surfaced to security. And I'm not going to go into those too much today, but I will give a really rudimentary example of a workflow. So let's take a hypothetical situation where a developer, commits some changes, adds them, and opens a pull request, pushing them. And these changes seem pretty benign at first, but Semgrep runs a scan on the pull request on the changes that they've made. And Semgrep notices something. It says, hey, I noticed that you're taking data off of this HTTP response, and then you're using it in the URL of another HTTP request. And so Semgrep raises this as an issue in the pull request to the developer, saying, this might lead to SSRF, and you really should be performing validation and sanitization on that potentially user-controlled data. That's awesome. That's great. I'm glad we're tackling the issue early. However, there's one problem. The developer was actually validating the data that came in. It was using this homegrown validate proxy request function that unfortunately Semgrep just, of course, doesn't know out of the box, right? However, Semgrep as a SaaS tool is pretty flexible and gives us ways to deal with this. So a traditional way to kind of work with these false positives would be modifying the Semgrep rule itself. So we could take the snippet of code, that validator, and we can then go and look at the Semgrep rule. Semgrep rules are all open. They're very transparent. You can see why the rule runs. You can fork it. You can modify it. And in this case, this is a data flow rule. So here's my rule. It's a YAML file. Um, the rule itself is two major elements: pattern sources, so where is potentially tainted data coming in; pattern sinks, which define where the vulnerable places that data needs to reach for the rule to match and identify a finding. And we can add our own little custom sanitizer by adding a pattern sanitizers block. And so I just need to write down the function that is used for sanitization. And now Semgrep will recognize that in the future, that whenever data passes through that validator, it can be considered as safe, and you know we don't need to raise this false positive. So simple solution. Took maybe a minute of my time, um, but it's not very scalable or flexible. Let's say the developer in another part of the code uses a different validator called checksafe. Fortunately, our rule is not flexible enough to capture that, and so we would need to go and modify it and change it again. Um, and with very large companies, very large variety of code bases and styles, you've got acquisitions, you've got legacy stuff. This can become really unruly. Um, So we really wondered, how could we improve this process and make things more flexible? How could we complement the more rigid and deterministic nature of a static analysis solution with a solution that is context aware, um, that really has the advantages of being able to adapt flexibly to new contexts, and ultimately perform a degree of higher level reasoning? And so we thought bringing generative AI into the picture might be fruitful. Now, as an interesting aside, we actually did an experiment seeing what would analysis be like if we just did AI. And our researchers took a pretty serious crack at trying to implement an AI-only solution. Um, Tried a whole bunch of different models, chaining them together, different prompting strategies, techniques, different sources of data. Um, and after a month or two of that, we really concluded that we really could get like maybe 5 or 10% true positives. Most of it was junk. Um, so what we found to be highly effective is not pure static analysis, pure AI, but a marriage of the two. Um, And that process really looks like taking the Semgrep Pro engine, which is a deterministic output, as the basis of our analysis, and then bringing the AI on top to provide triage recommendations. Do I think this is real? Is it safe to ignore? Bringing in contextualization. Do I think that this code is in a risky component that might need to be prioritized? And then last of all, bringing in remediation advice. So what would a fix look like for this code base? What would it look like given your organizational standards, or compensating controls, et cetera? And so this kind of blend has really helped us deliver on those promises that I made earlier. Um, a couple months ago, we released this new feature called noise filter for pull request comments. So when we reach out to the developer in their pull request, we run a pull request scan. If Semgrep Assistant takes a look at a finding and thinks this is likely a false positive, we're just going to hedge our bets and not opt to not even notify the developer. It's better that we do that than risk sending out something that is kind of spammy and noisy, wasting their time. And second of all, anytime that we surface problems to a developer, we are able to offer them inline remediation advice. So here's an example of a pull request with an inline fix that the developer could commit right away, as well as step-by-step instructions for them. This isn't always perfect, and we all know that LLMs are not perfect. They hallucinate, but this at least gives the developer a starting point And even if it isn't the most ideal or opportune thing, it can still shave 10, 20, 30 minutes off the time that they might spend on each of these issues. And we've seen that play out again and again. And lastly, we have the ability to tailor assistance responses to your code and business context. So Semgrep Assistant will learn from the historical fixes made to similar issues. Um, so it can say, hey, if your organization has previously fixed things this way, I might recommend a similar fix. And they can also, you can customize the guidance based off of instructions that you provide in a natural language. So here I've got a super basic guidance of just like, as a standard, we leverage JSoup to sanitize our input. Easy breezy, and Assistant, you can see that incorporates that into its remediation advice. Now this learning and memorization ability is what we call Assistant Memories, and is really going to be the focus of my discussion today. So I'm going to go over, how Assistant Memories work. I've reviewed hundreds of memories that our customers have made, and I'll go over kind of the characteristics that I find in ineffective memories and the things that make a memory very likely to be effective. Now, ideally, we want our memories to scale our application security knowledge and, triage history, remediation history, um, so that we can really apply that to our backlog of findings and also to findings in the future. So let's take an example of the same triage scenario as earlier, but let's take a look at trying to solve it from the angle of AI and Semgrep Assistant. So I'm looking at the same finding now here within the Semgrep Cloud Platform. Um, so we can see, this potential SSRF issue. We've taken a look at the code. We said, hey, I think this is a false positive. There's actually validation going on. And so I'm going to click on the open thing, select, hey, I want to ignore the issue, provide the ignore reason, maybe leave a comment. And I could just triage it immediately, or I could triage it and add a memory so that I can kind of preserve some of that knowledge. So when I click ignore and add memory, the memory module is going to pop up. And I first need to choose, like, what is the scope of this memory? Does it just apply to this repo, or does it apply to multiple repos? And is it just for one rule, or is it for every SQL rule, that kind of thing? When I create a memory here, I really want it to be generalized past this specific finding. And so we don't want to just write a memory that says, hey, when the tainted data flows through validate proxy request, it can be considered safe. If that was all we were going to write, we might as well just modify our static analysis rule like I showed earlier, which would give us a deterministic, review. We really want to take advantage of the advantages that an LLM offers, namely its adaptability. And so we can write something more like this. We generally will use some sort of validation on user input. If there are functions that are named some variation of validate, sanitize, or clean that process user input, mark the finding as a false positive. So we can now save this as a memory, and Assistant is going to use it in future prompts. We can also ask Assistant, hey, I've got 43 other findings that are similar to this one. How about you rerun our triage and remediation for those findings and see if they update with this new context that I've added with this memory. And indeed, when we identify similar false positives in the future, Assistant will call them out and filter them. If we have that noise filter on, Semgrep Assistant is going to say, hey, I think this is safe to ignore. It's using a validation function. and just not even show this to the developers. Of course, at the end of the day, we need a human in the loop, and Assistant is never going to make the triage call for you. You still need to accept or reject it from a security side, but we are doing this for the good and benefit of the developers and ourselves to save us all time. So that's the basics of using memories to scale your application security context in triage and remediation. But I'd like to get into, what makes a memory good and what makes it not so good. At the end of the day, when you're working with an LLM, not every prompt is going to get you the results that you want. So what makes a prompt effective? Well, there's a few ground rules, and none of this is groundbreaking stuff, but I think people don't necessarily sit and reflect before they work with an LLM unless they've really gotten used to it and done it a lot. Um, so the first question is, how do I talk to Assistant? What kind of style should I, incorporate in my dialogue? Um, and I think we find the most effectiveness when you talk to Assistant as if it was a new security intern at your company. How would you present and describe things to a junior? How would you guide them? You probably wouldn't leave things very ambiguous or give like super technical advice without kind of an explanation of the consequences of it. Um, you really would break things down for them. So that's the first thing is, you know, being verbose, being clear, being specific. Second of all, when we're going to create a memory for Assistant, we really want to decide what activities is this memory going to influence? Is that going to be triage, or is it going to change our remediation guidance, or maybe both? And so it's important to keep that in mind. What is the purpose that I'm trying to achieve? And then lastly, what is a common structure of a memory? Well, um, I think here's the ideal structure. Not every memory is going to have these three components, but I think it identifies what conditions Assistant should be looking out for in the code base, um, or other context, and then a guidance as to how do you identify those conditions, and if they are found, what are then the implications for either triage or remediation. So those are the elements that should be present. So I want to go over some successful memories and see those three elements kind of incorporated and at play. The first is these are real world examples. This is a Fortune 100 customer who had a large backlog of SSRF findings. Um, and they noticed a pattern in the false positives that kept popping up. The first was that a lot of static data was being used in a URL, being pulled in from elsewhere in the code base. And Semgrep wasn't necessarily identifying that it was static, and thought it might be user controlled. And second of all, data was coming in from internal services that were defined in other repos. And Semgrep, of course, can't tell that that's an internal service, it's not user controlled. And so that was causing a number of false positives for them. And so they created two different memories to deal with these issues. The first, says that SSRF is likely mitigated if the base URL is hard-coded to constant data and configuration is managed securely using Spring's configuration framework. So there's our conditions. To triage SSRF vulnerabilities, check if URLs are sourced from secure configuration settings and assess secure handling of sensitive data. That is the way by which Assistant should assess whether the conditions are present or not, right? And then third of all, for true positives, the base URL should be manipulated by dynamic data. So here are the consequences if those conditions are present. And then the second one, a lot simpler. Data from our internal services, such as blank, blank, and blank, are trusted sources for data flowing into the URL. So with just these two memories, they were able to rerun Assistant on their entire backlog and reduce it by about 40%. And here are some examples of the responses that Assistant then gave with these memories in mind. So memories can be pretty powerful, um, especially when you have a backlog of issues. Um, and it's something that we've seen borne out again and again. Um, saving you time in terms of like the triage that you need to do, and yeah, really future-proofing scanning and findings for your developers. Second example I have of real-world tuning is for cookies. This was a smaller, uh, like small to medium-sized customer who noticed that a lot of their findings were flagging, uh, cookie management activity where they weren't properly setting security attributes on the cookies. But they said, hey, we're taking a look at these, and some of these, some of the management is deleting or clearing the cookies, and that really, doesn't require those attributes to be set. And so they wrote a memory that says, hey, if it is deleting or clearing a cookie, those security attributes may not be necessary, and it may be a false positive. And just like that, they were able to kind of remove that 15% of the backlog that was related to that issue. Um, so that's the power of a good memory, a memory that really looks beyond the initial issues that you noticed some false positive noise around, and tries to create a generalized memory and way for Assistant to carry that knowledge forward into its activities. So keeping those, I think, gold star examples in mind, um, let's take a look at some of the common challenges that I see with memory creation. At the very end, we're going to take a look at some of our okay memories and try to improve them together. Uh, but let's take a look at our Hall of Fame first. So I would say one of the very first initial mistakes that a lot of people make is that they failure to try to write a memory that applies beyond a single finding. They're like, hey, this finding has a false positive, and I want Assistant to, change its advice for this one finding. But there's no thought to the greater kind of history of triage that's going to take place. So, for example, someone says, hey, in this, maybe SQL injection finding, the interpolated value does not involve user input. That's great for that single finding, but it doesn't really apply outside of that. How can Assistant identify in future code whether that interpolated value does not involve user input? Might be the case for this, but it may not in future code, right? And so we might change it to something like interpolated values that are program constants are not considered dangerous. So that Assistant has a way, it knows what it's checking for and the implications of that check that go beyond just this finding here and now. The second is this function is called through generated methods, making it unreachable in this use case. Great memory for this use case. But again, how does this memory actually scale our knowledge? So we might actually tell Assistant, yes, functions that are called through generated methods are safe, and we know methods are generated when they are from framework X, so it's some standard function that looks a certain way. Or we could even copy and paste what generated functions look like, and we could paste that into our memory so that Assistant has samples of code that it should be looking out for. So again, we've got the condition, the generated methods, and now we have a way for Assistant to actually identify if the condition is present and the implications, of course, if the method is generated. Now, the next major error that I see are just not being clear about what your implications are and the consequences are for Assistant. Oftentimes, this is just like stating a fact about the state of affairs. Um, so, for example, the code is located in a QA repository. That might be very factually correct, but what are the implications for that? Uh, you know, maybe we say this is a QA repo and findings from this class of vulnerabilities can be safely ignored due to mitigating factors from blah, 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 blah. Um, so we really want to state beyond just what the fact is. There's another one where we identified a secret and the customer said, hey, we're using this function generate dev secret to create that secret. And that's used for creating development secrets. Great, factually true. However, what are the implications? I have worked with orgs where development secrets can be just as powerful and damaging as production secrets, and they consider them just as dangerous. And I work with other orgs where development secrets are ephemeral and they don't care if one is exposed or anything like that, and they downgrade those as false positives. So you really need to be clear, what are those implications? And lastly, this Docker file uses an image which is designed to run a server as a non-root user. In this case, the rule identified that they didn't specify what user it was supposed to run as, and the customer said, well, you know what, it actually does. But again, what are the implications of that? Is that an acceptable risk? And also, you're saying the Docker file uses an image. What is the image? So that Assistant can easily say, it's these images that I'm looking out for. So Docker files with image X are designed to run as a non-root user and are an acceptable risk. So that is the category of unstated implications, and where we're just not being clear enough what we want out of Assistant, which will lead to unpredictability in its responses. As a third and final category, just a misunderstanding of what the LLM can do and what it's actually looking at. When Semgrep Assistant analyzes finding, there's a few things that it brings into the analysis. It brings in the actual code that was matched by Semgrep, along with 30 lines above and beyond each point in the data flow of the finding. It brings in the Semgrep rule. It brings in examples from an application security knowledge base. And it brings in, of course, the memories that you've written, as well as prior fixes for similar issues. So all of that is going into the stew of our prompting and generation. But there's some things that are just not going to be present. For example, and I think this one is a common trip up, Assistant is not going to use past remediation advice in a prompt. So if you write a memory that just says, hey, you provided this solution and I want an alternative one, and in your new remediation advice, Assistant doesn't actually know what its past remediation advice was. And so it's just going to hallucinate it. So we want to be very clear. If Assistant recommended, for example, using this validation library X, and we don't want to use that in our remediation, just make that clear in your memory. Fixes should be generated with an alternative to the validation library X. Another thing that I see people do is post links. Assistant cannot follow links and it can't read what's behind them. So, in this case, the user says, hey, refer to this fix that's located here. Assistant can't do it. It's just going to make something up. So instead, pull out that fix or steps to that fix and put them into the memory. Recommend a fix to me, Assistant, that's similar to this code, and then just copy and paste. And then lastly, asking for context that we just can't get at all. So in this case, we found an API key, and the customer said, hey, API keys from a forked repo pose no risk for the company. That's great. Assistant can't tell if the repo is forked. In fact, it's really hard to programmatically tell if a repo is forked because technically every instance of the repo is kind of a fork. So it's not very meaningful, and there's no way that Assistant is going to be able to tell that. So instead, dictate to it. Repos, blah, 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 are forked repositories, and API keys found in forked repositories should be triaged as false positives. So being very clear and direct in what you want and what you need. So that concludes kind of my three main categories of errors that I see in sort of ineffective prompts. The first being those the kind of like failure to generalize beyond this finding here and now, the unstated implications, not being clear about what the consequences of a condition being present are, and then just misunderstanding what an LLM is really capable of, trying to ask it to do something outside of that. I'm now going to move to the next section where we take everything that I've discussed. We've had the chance to look at highly effective memories. We've looked at some not as effective ones and seen how we could maybe modify them. And I'm going to open up the floor to you as the audience and see, take a look at a memory, have you critique it, think about what are the ways in which maybe it could be improved, and share those in the chat. So if you're all ready, I'm going to post this first one here. This is a memory for, I guess, SQL injection issue. The customer said, the generated SQL doesn't work in Databricks. I'm going to give you 30 seconds to a minute to see what your ideas are in chat, what ways in which maybe this is ineffective, and how you would approach rewriting this to be more effective for either triage or remediation advice. All right. I haven't gotten any responses yet, but in the interest of time, I'm going to keep moving. So as we take a look at this memory, the generated SQL doesn't work in Databricks. A couple of things jump out to me. First of all, we're asking Assistant to reference past remediation that it generated. It's not going to know what that is. So is there some kind of specific part about the SQL that was generated that jumped out at us? Is that something that we can mention and say, hey, try not to include SQL that looks like this or uses this function or whatever? And this doesn't really generalize beyond this one finding. You know, it's referring to a specific remediation advice for a specific finding. maybe we improve it to say, when generating remediation for SQL injection issues, um, ensure that the SQL is compatible with Databricks, something like that. Um, that is some of the changes that I would make to this. Now, here's another one. So the Semgrep identified a potential secret, and the customer said, hey, if the secret has a lack of entropy, it likely indicates a false positive. I'll give you about 30 seconds to a minute to kind of drop some ideas in the chat, and then we'll keep moving. All right. So yeah, when we take a look at this, I think the thing that jumps out at me, we do have a condition here. We've got the implications of the condition, but the problem comes when we want Semgrep Assistant to detect the condition being, of course, lack of entropy. Um, LLMs can't do entropy analysis. Um, you know, they might be able to say they might be able to take a crack at it, but they're not going to give a very accurate result, and they're probably just going to guess and hallucinate. So we're really asking Semgrep Assistant to do something that it's not going to be able to do. Um, and so maybe there's some other information that we could ask instead to pull in for it to use to detect the secret is a false positive. And as a very last example, it's very verbose. This customer saw that there was a potential command injection. Um, so and they said, hey, the function argument that was provided is a static string created with this function, whose parameter is also a static string, ensuring no input could modify this specific execution call. Give you about 30 seconds to a minute to think about this one. You teach to distinguish between a secret and a hashing function that is not used for secrets, asked Nabil. Yeah, there is actually an example of a customer who codebase was kind of interesting. Anytime that there was a static string in the codebase, it had to be hashed. So there were a lot of very long, very entropic strings that were benign. They weren't API keys or anything. And so um, Semgrep, of course, is like, this is a problem. But the customer is like, actually, no. Anytime we use one of these strings in the code base, it's decrypted, or it's either hashed or decrypted in this way, and that logic takes place before it's used. And so that's something we were able to write a memory for, was to actually identify, those encryption, decryption behaviors, and bring that in, and it reduced their false positive rate by a ton for these generic secrets. If that helps answer the question. Yeah, I think for this final one, let's say in terms of critique, again, this is referring to a single finding. It really is about that the things that went into that single finding. It's not really generalizable beyond that. Um, so we may want to say, like, when we're using static strings, um, which can be, from this utility class and these methods in the utility class. Um, this means if that reaches like an execution call that looks something like this, it would be a false positive. And so just making it a little more flexible, a little more generalizable. And that is the third and final collaborative example that I wanted to share. So we've gone over a lot today, just the basics of Semgrep's kind of method of taking on shift left and trying to increase the experience and the quality of the experience for developers as well as security. The way that we're doing that with Assistant Memories, what goes into making a good memory, what makes memories less effective, and we've taken a look at some examples there. So before we depart, I want to talk about more about what's on the horizon. We've got a lot of stuff baking in the AI oven, so to speak. Um, and so right now, Semgrep is really delivering on the triage, the prioritization, and the remediation front. But in the future, we are coming up with some automatic, pull request creation. So being able to open a PR on the right place with the right code owner automatically. On the supply chain side, using AI to identify when breaking changes will take place when you're upgrading a dependency, so that you're able to avoid those changes when you're kind of working with your dependencies. And then really on the rule piece, helping recommend how rules should be set, what your security policy should be, and also write some grep rules for you with the help and suggestions of AI based on what we've seen in your code base. So that's really the future and where we're going to, trying to have a complete loop with AI assisting you at every single step of the way in your application security scanning program. So with that, I'll wrap up with Q&A. If you have any questions, please drop them in the chat. Stay on for a few more minutes. And if not, I hope you have a lovely day.